Bunsen was born on March 31st, 1811, in Göttingen, Germany, the youngest of four sons, as his father was a professor of modern languages at the university. An academic environment would surround him from birth. After schooling in the city of Holzminden, Bunsen studied chemistry at Göttingen. Receiving his doctorate at age 19, Bunsen set off on extensive travels, partially underwritten by the government, that took him through Germany and Paris and eventually to Vienna from 1830 to 1833. During this time, Bunsen visited the Hirschfels machinery manufacturing plant and saw the new small steam engine. In Berlin, he saw the mineralogical collections of Weiss and contact with Runge, the discoverer of alanine. Continuing on his journeys, Bunsen met with Lindenberg and Janssen with his Mitscherlich in Bonn for a geological trip through the Eifel Mountains. The essential piece of laboratory equipment that immortalized the name of Robert William Bunsen was not invented by him. Bunsen improved the burners to aid his endeavors in spectroscopy. Ironically, Bunsen will be remembered by generations of chemistry students for the mere improvement in a burner, when his other contributions to the field of chemistry are vastly more significant and diverse, covering such areas of organic chemistry, arsenic compounds, gas measurements and analysis, the galvanic battery, element spectroscopy, and geology. Gustav Kirchhoff's father was Frederick Kirchhoff, a law counselor in Königsberg with a strong sense of duty to the Persian state. Gustav's mother was Johanna Heinrich Wicke. The family were a part of the flourishing intellectual community in Königsberg, and Gustav, the most able of Frederick and Johanna's children, was brought up to think that the service to Persia was the only course open to him. University professors were civil servants in Persia at this time, and so doomed to become a university professor. Gustav's parents believed represented the right position where someone of high academic abilities could serve Persia. Given Gustav's academic abilities at school, his future career followed naturally. The year 1847 was an eventful one for Kirchhoff. He graduated from Königsberg in that year and moved to Berlin in 1847. At a particularly difficult time when tensions were high due to poor conditions in the German Confederation, unemployment and crop failures had led to discontent and disturbances, and trouble sparked by the news that Louis Philippe had been overthrown by an uprising in Paris in February 1848. There were revolutions in many German states, and fighting in Berlin, Republican and socialist feelings meant the monarchy was in trouble, but Kirchhoff was in a privileged position and was unaffected by the events around him as he pressed forward with his career. He taught at Berlin in an unpaid post from 1848 to 1850, and it was while he was working in Berlin that he had corrected the accepted understanding of electric currents and electrostatics, which were referred to. He left Berlin for Berlitz in 1850 when he was appointed extraordinary professor there. When he arrived in Berlin, Kirchhoff solved a problem concerning the deformation of elastic plates. An earlier form of the theory had developed by German and Poisson, but it was Navier who gave the correct differential equation a few years later. Problems remained, however, with Kirchhoff solving using variational calculus. When Kirchhoff was in Berlin, he met Bunsen, who spent the academic year 1851 to 1852 there, two of them becoming firm and lasting friends. In 1854, Bunsen, who was working at Heidelberg, encouraged and supported Kirchhoff to move there. Kirchhoff accepted the offer, an appointment as a professor of physics, and he began a fruitful collaboration with Bunsen. He shared the academic and social excitement generated in Heidelberg, where the circle gathered around Helmholtz. In 1857, he married Clara Richow. She was the daughter of Friedrich Richow, one of the mathematics professors from Königsberg. The origin of the name comes from the Latin word Ceasium, meaning sky blue. Ceasium is silvery gold, soft, ductile alkali metal. It is liquid in a warm room, melting at 28.4 degrees Celsius, making one of the few elemental metals which are liquid near room temperature. Mercury is the only metal with no melting point lower than cesium. Cesium is an extremely reactive metal and the most alkaline of the elements. It reacts explosively upon contact with water, producing cesium hydroxide, an extremely strong base that can rapidly corrode glass. Cesium is an alkaline metal and has physical and chemical properties similar to those of rubidium and potassium. The metal is extremely reactive and acidic, reacting with water even at negative 116 degrees Celsius. The cesium is also larger and less hard than those of the lighter alkali metals.